Ready for some more examples? I know you are because you're a go-getter, you're watching all these videos for school and trying to get a good mark. So you know what? Why don't we do as many questions as possible so that you see everything that could be on your test or your exam. We're going to start on E, okay? So continuing from the last video. All right, this is a log equation. I can tell because it has logs. And it's an equation because it has equal signs. So my ultimate goal is to have one term on each side, okay? Then I could figure out what to do, like maybe change it to exponential form, or I might be able to just recognize that they look very similar to each other. Like I'll deal with that in a little bit. I just need to make sure that there's one term on each side. The problem is there's two terms on this side. There's a log and there's a 1. Okay, so you know what? We'll need a little bit more room. First, bring the log to the other side. If I can do that, I mean, I get a positive. This was a negative before, right? So if I bring this over, I'm going to get a positive log x minus 4. Since these guys have the same base, I could probably put them together using one of my laws. Now, the logarithmic law that this looks like, because there's a positive, is probably the product law. So I'm going to go like this. Keep the 1 on this side. Oh, that's nice. I have one term on this side. Oh, that's also nice that I could probably put these guys together so that I have one term on this side. Perfect. So product law is going to be these two brackets multiplied together. Okay. Now there's two different methods I can show you. One method, which is probably the easier one, I don't know why our class decided to do it together, and it ended up to be method 2. So I'm going to show you this one first. And the one that's a little bit more complicated is the logarithmic way to do it. And you can do it either way, you get the same answer. So I'll show you the easier way first, which is method 2 for some reason. Exponential form means that if I have this, which is what the question is so far, all right, I'm going to change it to exponential form. All right, so there's a base of 10. It's going to be my base. Then you got your exponent 1 is equal to, and then that answer part. From here, no more logs. I can definitely just solve this. Okay, so I'm going to go a little bit fast. 10 to the power of 1 is just 10. And then all the way down, I mean, like, you guys know how to solve this. You want a 0 on this side, so you got to bring the 10 over. You also have to expand this, blah, 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 blah. And once you refactor it, maybe I'm going too fast. Okay, one more time. Expand this guy, put things together, bring the 10 over, it's going to become a minus 10. You'll get your 0 on this side, which is great. And then refactor and solve, you're going to get a 5 and a negative 6. Okay. I also checked both of them, so take the 5 and check it into your x or your x, and you know what? If I put it into this x, 5 minus 4 is a positive number. 5 plus 5 is also a positive number. So this guy checks out. This guy, on the other hand, negative 6, if I put it into here, negative 6 minus 4 is a negative number. It can't have a negative domain. So already doesn't work. It's an extraneous root. So I think that's the easiest way to solve this. We can also use the logarithmic form, which goes like this. Okay, so let's just start off with this guy right here. Logarithmic form means that I want logs on both sides so that they look kind of similar. Why don't we change this side to have a log? Okay, and the way that we do that is we just change it. Right now it's a constant, but I know that 10 to the power of 1 is equal to 10. So why don't I just replace the 1 with the log base 10 and then answer 10. So I'm going to get rid of this 1 and I'm going to replace it with what it actually also equals to. So this is equal to 1, right? It's equal to 1, so I don't want this. I actually want this to match this guy because they both have the same log base 10. So remember, log base 10 to 10 is equal to 1, and that's why I just replace this 1 with this guy. Now they kind of match. So remember, if the logs match, then their answers, their domains must match. So this indicates that 10 is equal to x plus 5 times x minus 4, which is the same as what we had here. And then, well, you know what? I'll do more of it this time. Okay, so I didn't show you the steps this time. I'll show it over to you over here. Expand this and you get this guy. Bring the 10 over, you get a minus. So there's a minus 10 right here. Simplify it a little bit and then solve. Do you see? You get the same answer as here. So in both cases, x has to equal to 5 and not negative 6 because the negative 6 is going to be an extraneous root. Which way do you guys like better? because I'm thinking my mind goes towards method number 2, which is the exponential form. But I want to show you both ways so that we can practice. Here's f. Okay, so notice again, we have 2 logs on this side. That means 2 terms. I don't want that. There's only 1 term on this side. So maybe we can put these guys together since we have the same base of 10. All right, so since there's a plus in between, I'm thinking probably going to put them together with a product law. All right, so you're going to take the domain over here, the domain over here, and multiply them together. Let's just keep practicing that logarithmic form. Okay, so remember, this is going to stay the same, and we want to change this to match that log. All right, so remember, we can change the 1 to log 10, because log 10 is equal to 1. Since the logs match and the bases match, we can say this indicates that this guy, the domain, is equal to this part, the 10. Then we can easily solve using grade 10 stuff. Okay, so expand the brackets using FOIL or distributive law, and then bring the 10 over. It's going to become a minus, so that combines with the negative 2 to give you negative 12. And then you're just going to factor or use a quadratic formula. So I did the whole thing, and I mean, you guys know how to do this, all right? So I got 2 different answers. Always check your answers to see if they both work. So the 1.8 I put into the original x's, and it gives a positive number here, check mark. It gives a positive number here, check mark. But this guy, the negative 3.3, you're going to put it into here, and actually it gives negative answers, and you can't log negative answers. Therefore, this one is an extraneous root, and our final answer is approximately 1.8 only. I think that you guys are starting to see some sort of a pattern that negative answers seem to give you an extraneous root. Don't just assume that that's always the case. It's not. So just check really quickly with both in each of the brackets. Okay. All right. Oh, okay. This looks kind of complicated, but it really isn't. I mean, this is great. We already have 1 term on each side. Fantastic. So since we have a log on one side and a constant on the other side, I guess we could just change it right now into exponential form. Okay, so let's use exponential form. Base 10 goes down to the power of the answer. Well, I guess to the power of this exponent part, and then equals to that part, which is the answer. Okay, all you have to do is you solve this equation now, but this root is like really sticky. I don't really like that. It kind of looks ugly. Why don't we square both sides and get rid of that root? Okay, so if I square this side, the square and the root will cancel out, and I get this. These guys, okay, let's do a power of a power rule. So you just multiply the half and the 2, and that becomes a 1, which is invisible right there. You still get a 10. This looks very nice. Okay, this is doable. Just take the 10 over to the other side, becomes a minus, and then factor. Solve, and then check. Oh, okay, I guess both of these work out. Let's just check really quick. Okay, take the 5, put into both of these. So if I put a 5 here, that's 25 minus 3 times 5 is 15. Okay, that's a positive number. So does this one work too? Negative 2, put it in here. Negative 2 in brackets squared is positive 4. Minus 3 times negative 2 is going to be positive 6, so that gives you a positive number, and that works as well. So no extraneous roots here. All right, I jumped a little bit too fast. Here's h. Same type of thing that we saw before. Why don't we change it to exponential form? Okay, so 10 to the power of 1, which is this guy right here, is equal to this guy right here. Square both sides to get rid of that square root. And then we get x squared plus 48 on its own. 1 times 2 is going to give me a 2. So 10 squared is 100. Now bring the 48 over to the other side, and you get a minus. When I subtract these two, I'm going to get 52. And that's x squared, so why don't we square root both sides, and we get an answer, a positive negative answer. Again, you got to check both. So positive 7.2, if we put it in here and we square it, plus 48, that'll give us a positive number even if we square root it, so we're good. Negative 7.2, okay, if we put it in here, put brackets around it and square it, we're going to get a positive number still. Plus 48 and then square rooted it's also good. So both of these answers make sense, no extraneous roots. This is the very last example. I know I'm just throwing them at you one at a time and it's continuous, okay? So I know that you want to see all these, all right? Because you're probably going to get quite a couple on your test. All right, 2 terms on this side, 1 term on this side. Maybe we can put these guys together. I mean, they have the same base. There's a minus in between, so I'm thinking quotient law. Okay, so log 2, because that's what's similar. Quotient law goes this one on top, this one on the bottom, something like this, is equal to 8. Perfect. 1 term on each side. Then we can change it to exponential form. Okay, so 2, which is the base, to the power of your exponent right here is equal to this answer. Now we got no more logs, we can solve it. 2 to the power of 8 is 256. Then I'd probably cross multiply with an invisible 1 underneath, and you get something like this. So 256 times 2x is 512x. 1 times x plus 5 is going to be x plus 5, and just bring over the x so that it's together with that other x, and it's going to become a minus. So that's 512x minus 1x will give you 511x. Okay, the 5 is going to be on this side by itself, so let's get rid of that 511 and divide it on both sides. So your final answer is x equals to 5 over 511. This is a positive decimal number, so if I put it into here or here just to check, I'm going to get a positive domain on either side. So this answer does definitely work, and it's not an extraneous root. Okay, so you see there are so many different types of questions. I know it looks confusing, like what do I do in each case? Just understand that there are overall rules that you're using, such as our ultimate goal right now at the very beginning is to put 1 term on each side. From there, I can change it to exponential form. Then it's just a regular grade 9 or grade 10 type of solving question. You solve for x. At the very end, you always want to check for extraneous roots. Okay, we have one more chapter to go, chapter 8, and then we're finished.